And then we'll have a few more sections, a couple more quizzes, and then the final exam. Let's not worry about that. It's not happening yet. It's like a month. Month and a half. You're good. All right. So this is just kind of a continuation of the last section, just more types of equations you can solve that have trig identities in them. Most of the ones that you're going to see in this section are going to have a different kind of angle. So we're going to start with double angles here. I've got sine 2x equals to half. Here we're finding all solutions on the interval 0 to 2 pi. So we don't need to do the plus 2 pi k at the end of it. We want answers in radians. All right, so we're going to do these problems similarly to how we did the ones that had weird angles in the last section. There were a couple that had like theta minus pi over 4 or theta plus pi over 6 as the angle to start. And what we did was create a little substitution. We said let our angle, in this case 2x, let that equal theta, okay? And so we're going to replace it with a single angle and solve for that first. Sine theta equals a half. And if my sine wasn't alone already, we want to get it alone. And at this point, then, you can find all of these answers on your unit circle. Okay, so where on your unit circle is sine equal to a half? Pi over 6 is one of them. And 5 pi over 6 is the other one. Yep. Okay. All right. Even though I don't need it in my final answer, I'm going to put plus 2 pi k at the end of these. Okay, because that's the period times k, where k is an integer. And then once we've got theta solved for, we're going to go ahead and put back in our 2x that we started with. So 2x equals pi over 6 plus 2 pi k. And 2x equals 5 pi over 6 plus 2 pi k. All right. And then in both of those little mini equations, how do I solve for x? How do I get x alone? Divide by 2, or you could multiply by a half. I think that's going to be easier because you're going to have a lot of fractions as we do this. So think about everything's getting multiplied by a half. So pi over 6 times a half is going to be pi over 12. We're also going to adjust the period a little bit. If I do 2 pi times a half, it's just going to be pi k. Do the same thing for the other one. 5 pi over 6 times a half is 5 pi over 12. And then 2 pi times a half is pi k. All right, so if the problem said find all solutions, this would be your answer. Okay, we'd be done. We only want answers between 0 and 2 pi. So our first answer is going to be pi over 12. What that plus pi k tells me is every pi units after that, we're going to have another solution. Okay, so I'm going to do this on the board. If I have pi over 12, and let's say I add on 1 pi. Okay, so k is 1. What's the common denominator here? 12. Okay, so I'm going to think of it as 12 pi over 12 that I'm adding on. So 1/12 plus 12/12 gives me 13/12 is another solution. Okay, let's say I add another pi onto that. So now I have 13/12 plus 12/12. What's that going to give me? 25/12. Now 25 over 12 is a little bit bigger than 2, right? 24 over 12 is 2. And we only want answers between 0 and 2 pi. So that's how you know when to stop, because you're going to get something that's larger than 2. So the only two answers in this set of solutions that are between 0 and 2 pi are pi over 12 and 13 pi over 12. And this 13 pi over 12 is why we had to add on that plus 2 pi k in the word, because when I end up dividing by 2, it changes the period and it gives me additional solutions. All right, so now for the other one, I had 5 pi over 12. If I add 1 pi to that, what do I get? Not 10, it's going to be bigger than that. Again, think of it like 12/12. It's going to be 17 pi over 12. If I add another 12/12 to that, I'm going to get 29 over 12, which is bigger than 2. Okay, so those 4 solutions are the only 4 solutions that occur between 0 and 2 pi. Okay. All right, let's try the next one. Cosecant of 2x equals a half. So I'm going to start by replacing my 2x with a theta. Cosecant's a little hard to find, so what could we change it to? Sine, I could do the reciprocal. So sine would be equal to 2. Where does sine equal 2? No solution. That's a quick one. All right. Good there? Okay. All right, let's try this one. Cosine 3x equals a half. So again, I am going to put a theta there and solve the easier equation first. 3x equals theta. All right, that's on my unit circle for sure. There should be 2 of them. 2 places where theta, cosine theta is a half. 1 in quadrant 1 and 1 in quadrant 4. Pi over 3 is the first one, and 5 pi over 3. And in this problem, we're still looking for answers between 0 and 2 pi. But remember, we want to, in the work, and you can really do this for every single trig equation you ever solve if you want to include that in the work. It's never going to hurt anything. But here you need to. It's going to give you extra solutions. Okay, and again, it's plus 2 pi k because that's the period of cosine. The only time you use anything other than that is with tangent or cotangent. Remember, that's just pi. All right, put back in my 3x that I started with. 3x equals 5 pi over 3 plus 2 pi k. And then in both of those cases, how do I solve for x? Divide by 3, or think of it as multiplying by a third. Okay, so we're going to multiply through a third. So that gives me x equals pi over 9 plus 2 pi over 3k and 5 pi over 9 plus 2 pi over 3k. So my first 2 answers are pi over 9 and 5 pi over 9. Now the other answers, if I have any more, are going to come from that plus 2 pi over 3k, which just tells me keep adding on 2/3 pi until you are past the 2 pi limit that we have here. If you want to, guys, you can cross out that 2/3 and write it with the common denominator, which would be 6 over 9 for both of these. So that can make your adding and subtracting a little bit faster as you go. We're just going to add on 6/9 to the whatever I have to start. All right, so 1/9 plus 6/9 gives me 7/9 plus another 6/9 gives me 13/9 plus another 6/9 would give me 19 over 9, and 18 over 9 is 2. So that's a little too big. I know to stop. Okay. 5/9 plus 6/9 gives me 11/9. Add another 6 on, I get 17/9. If I add another 6 on, I would be past 18 over 9. So no more solutions. 6 solutions to this one. Okay. Questions there? Okay. All right. Let me see if there's one for you guys to try on here maybe. Hey, why don't you guys try this one? Flip ahead a little bit. Cotangent 3x equals 1. And here we want all answers between 0 and 360. Okay, so we're going to give answers in degrees. You can give it in radians first and then convert it, or you can just do everything in degrees. That's fine. I'll give you a few minutes. The end, but because you have to multiply a bunch by 180 over pi. But we should get 6 answers. If you had radians here, it would be, let's see, pi over 12 plus pi over 3k would be the radians. Then you'd have to convert. You do not have to list both things that come from the unit circle here. And if you did, you probably noticed you just got the same answers out more than once. So if you listed 45 degrees plus 180k, 45 plus 180 gives you the 225, which is the other answer on the unit circle. And then you'd have plus 180k into that one, and you're going to see you're going to get just repetitive answers. So if you have it, that's fine. You don't need it though. Okay, and then here we just divided everything by 3, multiplied by a third to get that 15 and that 60. So start with 15, keep adding on 60 until you get past the 360 mark. Okay, any questions on that one? All right, I just got 2 more problems for you today that we're going to look at. These 2. All right, so difference with these ones now, instead of an angle that's double or triple, or you might see one on the homework that's like quadruple, we've got an angle divided by 2, a half angle, okay? So what we're going to do is, again, start the same way. That way we don't have 1,000 different methods. If I have a weird angle, go back 1 or 2 slides. Yep, these are the ones we skipped over. Okay. So if we have a weird angle, we're going to replace it with a single theta or x or whatever you want to use and solve for that first. Solve the easier problem first. All right, so we've got to find, and it's a tangent one here, so I only have to list it 1 time, where tangent is equal to rad 3 over 3. So in quadrant 1, and you know it's not going to be 45 degrees, right? So it's either going to be at 30 or 60. Tangent is y over x. So I need to figure out how can I do a y divided by an x and get that. Well, that's going to happen if I divide a half over rad 3 over 2. 2's will cancel, and then you rationalize and you get the rad 3 over 3. So where does that happen at? Where y is a half and x is rad 3 over 2. Pi over 6 in radians. Plus the period times k. What's the period times k? What's the period of tangent? Pi, or 180 degrees if we're in degrees. Again, if you say the other answer is 7 pi over 6 plus pi k, you can. It's just already included in this set. All right, so now put the x over 2 back in. And now to solve for x, what do I have to do? Multiply everything by 2. So this time everything's going to get larger. Pi over 6 times 2 will give me 2 pi over 6, which reduces to pi over 3. And then 2 times pi k will be 2 pi k. So if the problem just said find all the solutions, period, this is it. These are all the solutions on the planet. If it says solutions then within an interval, 0 to 2 pi, we figure out which of these answers are within that range. So pi over 3, of course. And if I add 2 pi to that, am I still going to be under 2 pi? No. So we actually only get 1 solution for this. That's it. Okay. So last problem of the day is for you guys to try the sine one. Okay? I'll give you a couple minutes. Great. What'd you get? Nothing is right. So it does have answers, but it has no solutions on the interval 0 to 2 pi. So when you solve for where sine is negative, rad 3 over 2, you get 4 pi over 3 and 5 pi over 3. When I double those, I get 8 pi over 3 and 10 pi over 3, which in themselves are larger than 2 pi. So if I added 4 pi to that, it would be obviously too big. Now, one thing that you do want to check too is k is an integer, which means it could be a negative number. So instead of adding 4 pi, you could also go backwards. You could subtract 4 pi. But if I take 8/3 and subtract 4, it's not going to be still between 0 and 2 pi. I would get a negative number. And if I did 10/3 and subtracted 4, I would get a negative number. But it's worth checking because sometimes with these, it kind of shifts all our numbers to the right. And so we have to work backwards to find solutions. All right. Okay. We'll stop there for today. Tomorrow we've got 5 problems left, and then that'll wrap up the section and the chapter for us. So you guys have about 20 minutes now if you want to work on your 6-5 math Excel. Let's do tonight or your circuit training. And tomorrow we'll wrap it up Wednesday work day for 6-6. Good? Questions for me? Great. All right, I'll do cell phone lotto. And you guys are good?